start by kind of generally why we have model evaluation tools. Mainly because it's generally a hard process to do model evaluation. There's many model observational data sets we can compare our models to. And so having like a framework which can provide all the data sets you can compare your models to in a kind of abstracted way is really useful. So we have like multiple configurations that we can test. For example, site-based configurations or spatial configurations. We'll use different data sets to compare with. We'd also want standardized model evaluation. It's not really useful if you're trying to convince others if your model is actually performing well, if you're using your own kind of metrics and benchmarks. Ideally, you'd like to use standardized metrics and benchmarks so you can compare your results with other people, and this allows you to participate in the wider model community. And I guess the less time we have to spend on doing all this is more time spent on model development, and that's a plus. So I'll just give a brief overview of some of the tools that are being used. So ILAM is basically a Python package for confronting models with reference data sets, which just means comparing. And it's mainly model data comparison. And we also have modelEvaluation.org, which is a web application for evaluating and benchmarking models. And it's mainly allows, so correct me if I'm wrong, Gab, but it allows you to easily share analyses and data sets and model outputs with anyone in the community. And it's quite flexible in the type of analysis you can do. It's basically what you include in like an R script in a particular experiment. So it's quite flexible in that. And we also have Met Plus, and that's a Python scripting infrastructure around these things called Met verification tools. I'm not going to say too much about that because that's about as far as my knowledge goes. And we also have our BenchCab, which is what we're working on. It's basically a command line tool that runs cable in a bunch of model configurations. And important thing to highlight is that the tool doesn't actually produce any scientific analysis. It integrates with a model evaluation tool. So currently it integrates with modelEvaluation.org for the scientific analysis. And the goal of BenchCab is effectively to test cable in as many model configurations as possible. So it's easy for developers not to inadvertently break someone else's configurations. So just to give an update on kind of current and future developments with regards to ILAM, and talk about BenchCab in the next slide. So ACCESS-NRI has been working on improving the accessibility of ILAM. So it's now available on NCI. And we had a workshop training on Monday, if anyone was there, and that's basically the link to the workshop training. It has all the instructions of where you can access ILAM on NCI. We also have an effort with modelEvaluation.org where ILAM is going to be integrated within modelEvaluation.org. And I've heard it's already been pushed to the main repository, so it's available. And there's also an effort of making model outputs compatible with ILAM. So ILAM requires CF compliant model outputs. So for a future effort of ours is going to be make the output from cable to be CF compliant, so it allows for direct usage with ILAM. And the ACCESS-NRI model evaluation team is working on the fly seamerizer post-processing tool, which will help with making that more model outputs compatible with the tool. So BenchCab is available. It's on the it's available on NCI specifically on the HH500 environment. It's currently has supports for the it supports a test suite for flux site simulations currently. Plus the scientific analysis is available on modelevaluation.org. What's coming soon is a test suite for global and regional simulations, and an automated model evaluation step. And with our regional simulations, we're going to be aiming to use ILAM for the model evaluation. And there'll be a lot more details of this tomorrow. We'll give like a live demo. So maybe we can have a discussion about like model evaluation tools. Does anyone have any feedback for any of these tools? Are there other tools that people are using in the land service community? And are there other needs, for example, specific to evaluation that aren't satisfied by these tools? Or that's basically the end of my talk.
Okay. Any questions or discussions for Sean? Yeah, again.
Thank you. So I think you said ILAM will be available through ACCESS, right? So how is that different from running ILAM straight from the Python package?
I think it's basically just installed in Conda environment on NCI. So I guess that's kind of what it means for me. It means just when it's available.
So did you talk about running ILAM from modelevaluation.org, or you said from ACCESS? From ACCESS.
I suspect that that's about level of support, particularly for new users. So, sorry, just to clarify, I suspect that this is really around the level of support for new users we have, and particularly as new data sets get brought in, the new metrics, it's going to be a lot easier to do that via a centralized system rather than having to have lots and lots of people having their own individual implementation. So I think it's good to have it. Unfortunately, Jürgen, you were first off the rank and had to do it all yourself.
If I can add a bit on this topic as well, using the installation, the med team, the modelization team at ACCESS-NRI is also happy to provide support for people who want to add data sets to the ILAM data sets, because ILAM comes with its own data set collection. So all the collection is now available at NCI. And they're very happy to also collaborate to put improvement into ILAM for things we want to add to it.
That sounds useful, and I also have a test case for cable.
Anyone else?
So just to say that ILAM is working in evaluation.org. I don't know whether it's your plan to make BenchCab run the ILAM simulation through MEOG, but that would allow BenchCab to return a URL that would just give the user, rather than location or whatever, but the same spot. It all means the same spot.
How far off do you see a system where we can run the ACCESS model with cable for short simulations like 30 days, 40 days, and evaluate against observations? Is that, it feels like an absolutely essential step in terms of evaluating the emerging ACCESS models. Is that a year away, or 6 months, or 3 months? Do you know?
So that's the next thing that we're going to work on. That's probably the next thing we're going to work on after getting these spatial simulations going. We're going to be running these tests using the PyU framework. So hopefully that allows us to run a couple of models quite easily. Yeah.
And being cruel, you didn't answer my question, which was how long do you think it's going to be? I know. Do you have a sense whether it's 3 months, 6 months, a year? Because I'm interested in the timelines that have been given for CMIP7 and the needs for evaluation. Right. The boss is going to answer.
Yeah. I'm going to take responsibilities. I think it will be ready for ACCESS-ESM a lot earlier than ACCESS-CM, simply because they don't run under the same framework. And I would believe ACCESS-ESM is probably 6 months away, and CM might be later than that. Hopefully SM will be earlier than that, but there's also the holidays and stuff.
Do you want back the question I had earlier? So obviously CASA, when you train on the budget, you got a whole bunch of input there. If we have that in line as well, you'd be introducing ESM.
Yeah, I'm not sure.
No, it's a follow-up, but I'll let.
Yeah, we in the question of variables, it really depends on whether you have observations to evaluate against. So as long as we have that, we should be able to implement them. But that's more a question for Gab, who does the evaluation itself. That believes that's not a problem. And yes, there's a lot. Yeah. So we got, since we're going to back up on INAM without we can use what as INAM. If things are missing, it will be a problem of the community creating the analysis that is needed. We can help and support getting that into INAM. And
I suspect this is a question really for the broader community rather than Sean, but I'll put it out there. Many of the, particularly the Earth system components that we're interested in benchmarking against require extensive spin up. And so we've got to think about how to do this smartly, because otherwise we're just going to end up using all of our resources doing 1 or 2 spin ups to test, and we'll never get anywhere. Anybody got any thoughts how to short circuit that process? Because we can't be having to run 1,000 years ESM each time we want to test a new parameter value or something else like that.
so I was in the CMIP7 discussion yesterday, and Bob Harbour from GFDS said the way they did it, they typically choose the physical model, and then they did the carbon using the spin-up from the physical model. And they said that's how they got to do it faster.
Still spend lots and lots of compute time that we may or may not have access to.
I agree. This is the biggest problem with this automated science testing thing, which is really useful for the biophysics. But once you've got the carbon cycle stuff in there, you're going to have to make some assumptions that for some things that you're testing, restarts will do a lot of the work for you, and that you're happy for the fact that there's drift in the system or whatever, and otherwise you're not going to solve the problem.
I would, as a coupled person, I would turn around and say, well, things like that you're trying to benchmark, like LAI, whilst your biophysics are critically dependent on your LAI is critically dependent on what the long-term carbon cycle is. So you can't even do the short-term biophysics properly, venture without having done the full thing. So
that's true, but I think the biases that we know we have in the biophysics are bigger than we'll get from the recalibration. So we get to talk about next.